our next application, take a moment and copy this over. Oh, hey, I had to write it too. Annual sales in a company have declined from $8 million 2 years ago to $6.5 million today. Fortunately, the company has a lower limit of sales at $3 million. Tell you what, how that might happen in a moment. The question is, at this rate of decline, how long before sales drop to $3.5 million? Okay, so obviously the company is not doing so well in the last couple of years. Their sales have dropped $1.5 million. What's up with this lower limit? Imagine maybe the company has a huge contract with some other company, some other organization. So they know that as the years go by, at least for, who knows how long their contract is, maybe they're at least gonna be, uh, making sales of $3 million, right? So some other company, I don't know, maybe, they're, I, I'm trying to think of an example off the top of my head, right? So maybe they make some kind of, um, cutting edge technology, some kind of electronic. That'd be an easy one. Maybe they've got a deal with a car company, so that car company is always going to carry their particular electronic system, in all of their cars, right? I think Apple had a deal for a while with some major car company that they would always have their type of phone charger just built into the car. So if you had an iPhone, you could just plug it straight in. Um, so something like that. So they've got some huge contract. They know they're at least going to be selling $3 million worth. That's really nice for them. But otherwise, their sales, so even though this is going to be steady, otherwise their sales are dropping. So if it continues to decline at that rate, right, how long before they're down to 3.5 million? So they've got this lower limit that they know they're not going to go under 3 million. Okay, so could you identify which application you're going to use here? Well, obviously it's the second application for us, but if it was in homework or a test or something, whenever they mention a limit, right? So they're talking about some figures, and then there's a lower limit, or it could be an upper limit in a different question. Maybe a company has an upper limit of sales. Then you're gonna go with this equation right here. Let's just show it all. Actually, let's cover that up for now. You're gonna use the differential equation that describes growth, limited growth. There's a limiting factor. Okay, dy over dt equals k times m minus y. Obviously, we will need an initial condition as well. So we mentioned this really briefly back in the first video. What are the k and the m? So the m is your limit, and it could be an upper limit or a lower limit. Here, it's going to be the lower limit, 3 million. So we'll just put in 3 right there. What is the k? Well, just like in exponential growth or compound interest, that is still a percent. Okay, the k is still a percent. Here, it's a percent decrease because the company is losing money. Really, the point being still a percent. And we're going to have to calculate that on our own. It's simple if you know what to do, and maybe it's obvious to you here, maybe not. We're going to do that really quick at the beginning. So let's see. If we trying to, it's going to be impossible to keep all this on the screen, so let's keep as much as we can. What is k? Well, let me just show you the whole thing. The percent decrease. So they told us 2 years ago they made 8 million, but currently only 6.5. So we're going to take the difference, 1.5 million. And we're going to divide that by what you might say is like the first amount or the original amount. So it decreased by 1.5 divided by the original 8. The percent decrease was excuse me, 0.1875, 18.75%, 0.1875. What's important here is not only that, that you take the difference, but you always divide it by the first number, okay, or the original amount. Here it's the 8, because that's what it was, 2 years ago, and then it changed, so we base it on what it was 2 years ago. So if our company continues to decline at 18.75%, then when is this going to occur? The M, a little bit easier. Obviously, that's just 3. That's the lower limit, $3 million in sales. Okay, so we're going to put in these values. And we need an initial condition as well. Let me just show you all that. So putting in our value of K, our value of M, we got our differential equation ready to go to be solved. The initial condition. Turns out here we've got a choice of one of two initial conditions. They said 2 years ago they had $8 million in sales. Let's call that times 0. 2 years ago is times 0. They had 8 million in sales. So then today would be 2 years later. It's down to 6.5 million in sales. Because we were dividing by 8 back here, it makes a lot of sense to call that times 0. And then 2 years passed. There's our percent decrease kind of again. So when it comes time, the point at this point, I guess, is when it comes time to use an initial condition, we could use either one of these. Although people tend to lean toward the 0 because that's just usually easier to work with. But they will give you the same answer in the end. So we got that big OR. Okay. With the word problems, obviously the most difficult part is just setting it up, getting these two numbers, recognizing this differential equation, putting in your numbers, getting an initial condition. From here out, it's just a matter of solving. Just like with exponential growth, continuously compounded interest, we're going to solve this as a separable variables. How are we going to do that? Well, there's our function of y, this whole thing. We're going to divide all that over there. I think I've done that here. Let me recenter. We got to take that whole thing and divide it over. Of course, we'll multiply the dt over and integrate. Okay, it's all set up. Now the question is, can we do these integrals? So I'm just going to recopy that right there for us. Hey, well, this one doesn't look like a big deal, just a constant, but over here, how are we going to do this? Let's go with the u sub, and I'll just, whoa, I'm really showing you quite a bit of work all at once. No problem. These are hopefully familiar. So I've got my u sub, u equals that denominator. Look at my du, I need to move the negative over. So when I rewrite that left integral, I've got negative 1 over u du, which integrates to negative natural log of u. Okay, and on the right side, well, it's the constant, so I just copied it. But that integral, well, I'm just going to tack on the variable t, and the plus c goes on that side as well. And you can anticipate what's next. We plug in the u there. And okay, we've got an implicit solution. Pretty happy with that right there. We could solve for y if we really wanted to, I guess, but I kind of like that. Once we have our implicit solution, it's time to plug in to apply our initial condition. I'm going to go with y of 0 equals 8. So I've got my t value, my y value. put in that y, put in that t. This one's really nice because it just cancels out, multiplies by 0. And I've got my c equals negative natural log of 5. Here, this is where it's really important that you have that absolute value, right? Because if you tried to take the natural log of negative 5, that's not going to exist. Luckily, we have the absolute value, turns it into a positive. Negative natural log of positive 5. Which I don't know if that's ever come in handy before, that was an absolute value in any of your calculus. Until now. And here we go. Okay. All right, so I've got the value of c. What do we do with that? I'm going to put it back into my solution. And that is what we need to tackle the question. I'm going to go back. What was it exactly that they asked? At this rate of decline, how long before sales drop to 3.5 million? Well, where do I put the 3.5? T is time. The y is the amount of sales. Plug in y equals 3.5, solve for t. Okay, so let's do that. And we'll just kind of skip along to the answer at this point. Again, we've got the absolute value. We're going to need it there. The negative natural log of 0.5 equals 0.1875t minus the natural log of 5. So let's isolate t, right? We're going to add our natural log 5. We're going to divide by that decimal, 0.1875. And there you see it. I actually ran out of space on my page, so I just put it right over here. I rounded t as 12.28 years. And you can see I'm still covering up the final answer, because what was it exactly that they asked? How long before sales drop to 3.5 million? Hey, why isn't this the final answer? Well, remember how we define t, right? T equals 0 was 2 years ago. And t equals 2 was today. So how long would imply how long from today, I think, is the way any of us would read that. So we're going to take back those 2 years that have already passed. It will take another 10.28 years before sales drop all the way down to 3.5 million, which maybe in this day and age is quite a long time. So our company can, get a game plan together to get their sales turned around. I think it's not a total disaster yet if they've got over 10 years before they get that low. Okay, that was a good example. There's a lot happening there. We'll stop for now.